Hey guys, it's Miss Johnson here. I am here to bring you our 6-1 notes. We're starting a new chapter today, chapter 6. So today our notes are on the properties of exponents as well as scientific notation. Now, the first thing up at the top of your notes page, in order to simplify an expression that's containing powers, we have to rewrite the expression without any parentheses and no negative exponents. Okay, no parentheses and no negative exponents. The only other thing that we might want to consider when we're simplifying these, or one way to check that you have simplified it, is that you only see each variable once. So each variable should only be written one time. So that's another note that you might want to write down for yourself. So we should only see each variable one time. Other than that, there's no parentheses and no negative exponents in a simplified expression. Okay, so let's just review our properties of exponents. The first one we're going to look at is the product of powers. When we multiply monomials, we want to add their exponents. Add their exponents. So that's the first line in your little table there. The product of powers, when multiplying monomials, we add their exponents. Our two examples are x squared times x to the third times x to the fourth. These are all like terms, so I'm going to add their exponents. I end up with x to the 2 plus 3 plus 4, which is x to the ninth. Okay, my powers get added together. Same thing with m to the first times m squared. That's equal to m to the 1 plus 2, which is m to the third power. The power of powers property tells us that when we are multiplying, or when we are taking a power to another power, we multiply the exponents. So when raising a power to another power, we want to multiply the exponents. Similar to y squared to the fourth power, that's a power raised to another power. So I'm going to take y and multiply, that's equal to y to this 2 times 4, multiply those two together, and I get y to the 8th power. In the next example, this power of 3 that's on the outside needs to go to all parts inside. I raise everything inside to the third power. So 4 to the third power, if you type that into your calculator, it gives you 64. X to the second to the third, that's 2 times 3, so x to the sixth. And also y to the first to the third, that's 1 times 3, which is y to the third. Okay. The next property that we're looking at is the quotient of powers property. In the quotient of powers property, when we divide monomials, we want to subtract their exponents. Now our board got a little messed up here. This should have m to the 11th underneath it. So in our example, m to the 5th over m to the 11th, that is the same thing as we take 11 minus 5, which is equal to 6, but there's more on the bottom. Since m to the 11th is on the bottom, my extra 6 m's that are left over are going to be on the bottom. So this is going to be 1 over m to the 6th. Everything on top cancels out, and I'm left with m to the 6th on the bottom. Same thing down here. I have a to the 7th over a to the 3rd. Okay, a to the 7th over a to the 3rd. Again, I take 7 minus 3, which is equal to 4. But in this case, I have more on top. There's 7 a's on top. There's 3 a's on the bottom. So the 3 on the bottom are going to go away, and I'm going to be left with the 4 on top. So a to the 4th power over 1, which is just a to the 4th power. Now, how about negative exponents? When we're looking at negative exponents, we cannot leave negative exponents in our final answer. So to get rid of the exponent, we want to do this. Move it to the inverse side of the fraction, and then we make the exponent positive. Okay, so we move it to the inverse side of the fraction and we make the exponent positive. So for example, I have 3 times a to the negative 5th power. This a raised to the negative 5th, I can't leave that there. That's the only part that's being raised to the negative power. So that's going to need to move down into the denominator of a fraction. So what happens here is I leave the 3 on the top, In the bottom, I now have a raised to the positive fifth. So I move my power down and I make my exponent positive. Now when I have 2 over x to the negative third, 2 over x to the negative third, that x to the negative third can't stay on the bottom. So now I'm going to take this x to the negative third and I'm going to move it up to the top. And that gives me the 2 stays there. I haven't done anything with the 2. But now my x is raised to the positive third power. And I've canceled everything out of the denominator, so that's it. So switch the position in the fraction and make it positive. The one last power that we're going to talk about is the zero exponents power. Zero exponents say that any number raised to the 0 power is equal to 1. Any number raised to the 0 power is equal to 1. Now that goes for numbers and variables. Okay, so if I look at the first example, this whole thing, since there's parentheses around it, this whole thing is being raised to the 0 power. That means I have 5 to the 0 power and a squared to the 0 power. So that means this whole thing is going to drop out and just be 1. In my second example, however, the only thing being raised to the 0 power is the x. So x to the 0 power is going to drop out and be 1, and I'm left with 5 times 1, which is just 5. The 5 doesn't disappear because it's not being raised to the 0 power, only the x's. So now let's do a few examples of these. I'm going to take a look at number 1. In number 1, I have the product of 3x squared y squared times negative 4x squared y to the fourth. So I just want to combine my like terms. I can't have parentheses. I only want to see each variable one time. And I need to get rid of any negative exponents. So if I look at my like terms, I'm going to multiply the 3 times the negative 4. 3 times negative 4 gives me negative 12. I also want to put the x squared times x squared together. Now when I multiply those, I add the powers, which is x to the fourth, and put your y's together, y to the sixth. Now I have no negative exponents. I have a negative coefficient, but that's okay. It's not a negative power, so I can leave that there. Then I have only each variable only one time, and I have no parentheses left over, so that's as simplified as it gets. In number 2, I see lots of different sets of parentheses, okay? I'm going to start by moving my negative powers. I'm going to take my negative powers and move them down. So that means this one needs to go down below, and that one needs to go down below. So if I rewrite that, the things up on top are still a squared times b to the fourth. Now on the bottom, I moved a to the negative third down, so that's going to be a to the positive third power. And c to the negative 1, I bring that down, and that's c to the positive 1 power, or just c. Then I check if there's any more simplifying. I see 2 a's. I see a squared, and I see a to the third on the bottom. So I need to simplify those. Now I have 2 on top and 3 on the bottom. The 2 on top are going to go away, and I'm going to be left with just 1 on the bottom. So that ends up being b to the fourth power over a times c. Now I have each variable only one time, no negative exponents, no parentheses. I'm good. Let's take a look at number 3. In number 3, I have p to the third power is over p to the 8th power. Okay, p to the third power over p to the 8th power. So I need to think about where my extra p's are. I'm subtracting my powers. 8 minus 3 is equal to 5, but where are those extra 5? I have more in the bottom. I have p to the 8th power in the bottom. So I'm going to have the extra 5 left over in the bottom. This is all going to go away. That's going to be a 5. So it looks like 1 over p to the 5th power. I want you to go ahead and pause the video at this time and see if you can work on number 4 on your own. Let's flip it over and look at numbers 5 and 6. In number 5, I'm taking everything and raising it to the 5th power. So I have negative 2p to the third to the r to the second, all to the 5th power. So again, everything inside gets raised to the 5th power. If you plug this into your calculator, be very careful. You need to put parentheses around your negative 2. okay? Because negative 2 to the 5th power is actually negative 32, and we need to be really careful that our calculator tells us the right thing. So negative 2 to the 5th power is negative 32. Then I have p to the 3rd to the 5th. I'm going to multiply my powers. 3 times 5 is 15, so that's p to the 15th. Then I also have r to the 2nd to the 5th. 2 times 5 is 10, so that's r to the 10th. I have all my variables only one time. I have no negative exponents. Again, a negative coefficient is fine, just not a negative power. And I have no parentheses left. So that is my final answer. And again, at this time, I'd like you to pause the video and see if you can work on number 6 on your own. And that's going to conclude our video for today. Don't forget to go back onto Schoology and take the quiz, the video quiz that goes with it. Thanks for listening and have a good night.